Hello everyone. So in this couple of videos I will talk about statistics, then I will talk about the control charts. The statistics, as the famous quote says, so we have to use it and analyze it correctly. So therefore we have to understand the statistics. If we understand statistics, then we can analyze the data and we can do it correctly. That's the reason that we have to firstly have a small foundation in statistics. But this will not be just a in-depth analysis, it will just be the introduction. It will be the introduction to statistics. The outline will be, I will talk about the sample and the population, then frequency diagrams, histograms, some statistical terms, and then central limit theorem, which is very important in statistics, and normal distribution. The outline for the control charts I will cover it later. So the first thing is that I will start with the main manufacturing issue, which is the accuracy and the precision. The accuracy means that, as you can see from the figure here, all the points are around our aim. So this is our aim, or you can say this is the bullseye. And if the points are populated around the aim, we call it accurate. But the precision is low. Precision means that the densely populated around some point. Here they are not densely populated. And here you can see the precision is very good, but accuracy is low because our aim is here, but the points are away from the aim. In this case, the precision is low because we don't have the densely populated points, and the accuracy is also low because our aim is here, but the points are not close to our aim. And the last thing is that we have high accuracy and high precision. What it means is that we are close to the aim and the points are densely populated. So this is accuracy and the precision. Why we talk? Because in manufacturing processes we are never 100% accurate. So we have variations in the process. So the variations, as it says, none of the experiment or none of the manufacturing process is under 100% controlled environment. So since it is not under 100% controlled environment, so we will have errors. So the errors can be random, as the name says. So like you have a change in temperature, change in heat, it creates a variation in your measurement. Or you have the electrical noises that creates variation in your measurements. And these errors, they are random, as the name says, and you cannot control it. You cannot control it. This is just by chance, And the other type of error is that we have the systematic errors. But these systematic errors, you can control. Control means that you can decrease. And these errors, they are constant under fixed operating conditions. They can be, for example, we have a scale that does not consider the variation of the G. So let me say G, 9.81. It is not 9.81 everywhere. At some point it is 9.79, 9.83, but it changed, but our scale doesn't consider it. But this is something that you can fix. You can add a program to it so that it considers the variation in the GPS. Or we have a ruler, it shrinks under the temperature. You can fix that one as well. Or voltmeter has a 1 volt error. So what it means is that even if it is disconnected, it shows 1 volt. These are the things that you can decrease, or I consider you can control it. But it doesn't matter, you can control or you cannot control. We always have a variation in manufacturing process. And these variations, that is the issue that we are dealing with the statistics. So the variations means that we have the statistics. So why do we have statistics? Because we have the data. So we have variations, and these variations create data. So for example, you are looking for 20 degrees Celsius, but since your temperature is never 20, it's sometimes 20.1, it is 19.6, it is 20.2. So you see, you have a variation, you have data, and that data needs analysis, and that analysis comes from the statistics. That's the reason that you have to know statistics to look for and analyze your data. I will just give you one example. We have a gear, you can see there are failures on that gear, and this is just a variation here. Gear is not as you want. Okay, it is not as you want, but this is just one gear. But if you have the thousands of them, you cannot inspect all of them. So you cannot inspect and check all of the gears. So inspection is impossible. So because that much inspection means that the people, you need people for inspection. That people creates the cost problem and it needs time. So what you do is that you are not looking for all the thousands of the gears, you are just looking a couple of them. And then that's what we call it as the sample. But before talking about more about sample, let me give you some more examples. So that, say that you are trying to buy a car. You never test drive all the cars. You never do that. For example, you are looking for a Camry 2023. And you never go and check every car that's manufactured in 2023 and every Camry car. You don't do that. You just check one Camry, you just take maximum 2 Camrys, and then you have an idea. You have an idea about the features of the Camry, the comfort, speed, transmission, everything. Or some news agency or some government, for example, organization, they are looking for who is the next president. This one is the guess, yes. And for this guess, you are not checking the whole population of the United States. You are just looking for a part of it. Or in manufacturing, we have the mass production, which means we have thousands of the individual inspection. So which is not possible that you check all of them. It's not impossible. It's not possible. And the last thing is that we have the medical studies. If you are doing that, I can give you as an example here that you are trying to look for the influence of the COVID vaccine on the patients. So for this one, you don't check. So you don't check all patients. So what you do is that you check just some of it. And then from this sum, you go to the all. So what's happening in the all? So that is some of the examples that we never go with the population. So now comes the main point, that we have the population and we have the sample. So we choose a sample from the population and we use some sampling methods, and then we analyze the sample. And this is our the population means that this is our all data. All of the data is here, but you never check all the data, but you just go a part of it and you do a sampling and you choose your sample. And here I should say that choosing sample and it is also big job, it is not easy, it is hard. How do we choose sample? So that's another part of the process. But generally what we do is that we say that the sample should be less than 10% of the population. So say that your population is, say that population is that the 3000 and the sample should be that less than 300. Okay, this is the general rule. This is general rule. that we are going with the 10% of the population for our sample. So let me give you one example, then I will move to manufacturing example. That in Alabama, and you are looking for the happiness level of the people. So how happy are the people? You are checking it, yes, for the Alabama. What you do is that you choose one sample, you choose another one, you choose another one. And for these samples, you check for the happiness of the people. This is just one example. Or you can have a manufacturing process. You have the whole population. This is just the whole population. And from this population, you choose one sample, and you choose another one, and you choose another one. And they say that this is the diameter of the gear, yes, the diameter of the gear. And then you are looking for you are inspecting, are they all in the same diameter range? So you choose, for example, sample 1, and you choose sample 2, and you choose sample 3. And for each sample, you check the diameter, for example, here. You check the diameter, and you check diameter for each of them. Okay, and then instead of checking the diameter of the sample, I mean the population, you check the diameter of the samples. Maybe the population is, like I said, the 3,000. The samples will be less than 300. Okay, so you can even go with the one sample, or you can just go with 3 samples. It's up to you. So, as I told, the sampling is not easy. So it needs to be random. Random means that it is not planned. Okay, it should be just random, selected. Any of them is okay, and it should be unbiased. So what it means is that, I mean, say that I will give you one example that, okay, this is a very old example. Say that 1940s, yes, that they are trying to find who is next president. And then what they did is that to guess the next president, they made a polls by phone call. I mean telephone, actually not the phone. Telephone call. They made a polls by they called the people and then asked their opinion. Who are you voting for this election? And then they guessed, for example, that the person A will be the next president. Okay, this is by the poll. But the real election came that the person B is the president. This one is the real election process. And what is the problem here? The problem here is that there is a problem, because the problem is that the telephone on that time is owned by the rich people. Only the rich people has the telephone. So what it means is that when they did the polls, they checked the rich people's opinion. That's the reason that they get a wrong answer. So they checked the wrong person. I mean, they found out the wrong person as the president. So that's the issue, that with the sampling process, it should be random and unbiased. So it should not be similar to each other even. And then here another question comes out, that will you replace the sample or not? So it depends on you as well. I mean, you can replace it back or not. So for example, you take a gear and check its diameter, and you can replace it back or you can keep it. I mean, it depends on the sampling process. There is no rule that you cannot replace, and there is no rule that you can replace. You just mention that this sampling method has been used by replacing the pieces. Okay, this is the first part, and then next comes that we need to move from the sample back to population. So I will talk about this one in the next video.